All right, we're finishing up the Geometry A Quiz 5, version 1 on similar triangles. So this is question number 5, and I know on your paper there's, just a bunch of sentences, but I just kind of picked out the pertinent information. So we got a telephone pole. We're told it's perpendicular to the ground. Now, I don't think we cover that in class, so we'll talk about what does that mean. We got a shadow for the telephone pole that's 48 feet long. Ultimately, they're asking us how tall is the telephone pole. So I just put height with a question mark. That's what we're going to be looking for. And then we're also told about a stick that's also perpendicular to the ground. The stick, we know the height of the stick, it's 4 feet. And then the shadow for the stick is 6 feet long. So we're going to see how do we use this information to figure out the height of the telephone pole. So one good thing you might want to do, we were not provided with a diagram or a picture, so the first thing you might want to do is draw yourself a picture. We're talking about perpendicular to the ground. So to back up, perpendicular to the ground, perpendicular means it creates a 90-degree angle. Things that are perpendicular touch, cross, meet, intersect at a 90-degree angle. So 90 degrees, they create a right angle. They're perpendicular again, so that's 90 degrees. So the ground, I would probably in my picture draw that flat horizontal. So maybe this will be the telephone pole over here. So telephone pole maybe going up, and then the ground being flat, and then they're perpendicular, they make a right angle. Okay. And then I can talk about the stick as well. So for the stick, perpendicular to the ground, right angle. Now, let's see, what else here? The shadows, I'm imagining the shadows are going to be on the ground. So if this is the pole right here, and this is the ground where the shadow is going to be. Now, this is something, a realistic story problem where you could be like, yeah, I see that telephone pole. I want to know how tall it is. I want to know its height. But hey, on the ground, I could measure the shadow. We got 48 feet here. The stick, again, the shadow, I'm assuming would be on the ground. So we've got a shadow of 6 feet for the stick, and the height of the stick here, I do know that it's 4 feet. So we're looking for this right here. So you might put a question mark. I'm going to label that as X. This is my telephone pole. I want to know how high, what's the height of that telephone pole. So just looking at my diagram right now, you might be like, how does this relate to the rest of it that's on similar triangles? Well, the idea is that the sunshine, if you have, here's your sun, and the rays of the sunshine, the idea is that the rays of the sunshine are going to hit the pole and the stick at the same angle. So I don't know what this angle is. Again, we can kind of do like we did in number 4 and just be like, let's pretend, I'll do 30 degrees. Let's pretend this is a 30-degree angle. I have no idea. But then this is also going to be a 30-degree angle. That's the idea. The sun is going to strike, the rays of the sun are going to strike the top of the pole and the stick at the same angle. And so if that's 30 degrees there, then this is again going to be 60 degrees because that would be 180 minus the 90 minus the 30. And then you'd have 60 degrees here. So if we include the line that connects the top of the pole to the end of the shadow, or the top of the stick to the end of the shadow, what we have are similar triangles, big version, small version. And so now it's like the rest of the problems on this quiz. So yeah, if we're looking for X here, again, whoops, I'm losing my markers here. I would say, all right, if we do X in blue, and we want to talk about X corresponds to a side over here. Well, I can say, all right, well, remember to talk about corresponding sides are opposite from equal angles. So this side is opposite from a 60-degree angle. I'm pretending it's 60 degrees. This 60-degree angle over here, 4. X corresponds to 4. Okay. And again, now I only have 2 other numbers. But should we do 48 corresponds to 6, or should we do 6 corresponds to 48? Remember, we want to be consistent. So here I'd say x is coming from what looks like the bigger triangle. So in that case, in my next pair of corresponding sides, I'll stick with this triangle and I'll take the 48. And we'll do this one in green. So the 48 corresponds to, well, I'm guessing it's probably going to be the 6 because I don't have any other numbers over here. But let's just verify that. Corresponding sides are opposite from equal angles. The side length of 48 is opposite what we're pretending is a 30-degree angle. I have a pretend 30-degree angle over here, and that's opposite from the 6. So 48 does correspond to the 6, but yeah, just to make sure we have it in that order, because otherwise we could get in trouble. Excuse me. And again, if you can get this far, the hard part's over. Create a proportion. Let's see, where's that marker? It'll be x over 48, 4 over 6. And you can cross multiply and divide. We'll do 48 times 4. And divide by the 6, and I believe that comes out to 32. So I'm going to bring that back up there. The telephone pole is, according to this, 32 feet tall. There you go. I think your packet calls that indirect measurement. I think it's a cool problem. I've always wanted to take my class outside to do this, and just have never actually done it there. But to be like, yeah, if you assume that the pole and the stick are both perpendicular, if you assume that the rays of light from the sun are striking the tops of these at the same angle, you have similar triangles. And so we can use our similar triangles to calculate a side length and get the height of the telephone pole without ever having to be like, well, let's climb up and measure it from the top. I don't have to do that if I know how to use similar triangles. So there you go. That's the last problem on that quiz. I hope that was helpful.